So in this video, I'm going to be talking about extraneous solutions. I was talking about this with one of my students the other day, and I was trying to explain the concept to him. So first of all, what is an extraneous solution? Just by the word, there's extra in the name. So sometimes when you solve for x, you'll have multiple values, and some of them actually don't hold when you plug the value of x back in. The equality is not true. So those are the extraneous solutions I'm going to talk about in this specific case of square roots, why that happens. Okay, but let's first solve this example first, and then I'll go into conceptually what's happening. Okay, so if we want to solve for x here, we just go through the motions. So we need to isolate x by itself, but it's trapped under the square root on this side. So let's square both sides to get rid of that square root. All right, so as I just said, the square root and the square, they go away. So x plus 4 is left on this side. And what do we get on this side? Well, if we expand it out, you should know the formula, x squared minus 4x plus 4. Okay, let's solve for x. So we need to move all the x's to one side. So 0 is equal to x squared. That would be minus 5x, and we minus 4. So like that, x squared minus 5x. We can factor right here, so x times x minus 5. Okay, what are our solutions? X is 0 or x is 5. Okay, either when x is 0, 0 times who cares is 0. And when x is 5, 5 minus 5 is 0. So 0 times 5, that's 0 as well. So those are our two solutions. This is called zero product property here. Okay, so we're not done yet. As I said in the beginning, we might have an extraneous solution. So we got to check. We got to check both of them. If we check x is equal to 0, we just plug 0 back into the original equation. We would get 0 plus 4 is equal to 0 minus 2. Okay, can this be possible? Square root of 4, can it be negative 2? The square root, the output is always positive if it's a real number. So this is not true. So this is an extraneous solution. Now let's check x is equal to 5 as well. So we get 5 plus 4 is equal to 5 minus 2. 5 plus 4 is under the square root, so we get what? 9. So, and the inside, so it's 3 is equal to 3. Check. So x is 5 is our only solution. X is 0 is an extraneous solution. Okay? This is how we typically go about this. So now let's talk about why we have extraneous solutions. Okay? So I'm going to explain graphically what's happening. So let me pull up my phone real quick. So this is how the graph looks. Okay? Square root of x plus 4 is one function. That's this red one over here. X minus 2 is this linear one right here. And we see that this point of intersection is that x is equal to 5, which is what we found. Okay? So where does this x is equal to 0 come from? Okay? So if I just graph negative square root of x plus 4 as a third curve, you'll see why. So let me graph that real quick. Negative square root of x plus 4. Okay, so notice before, square of x plus 4 is this one. Negative square root of x plus 4 is this one down here, this green one. I don't know if you can see the colors on screen, but it's this one down here. So what is this point of intersection right there? What's the x value? It's 0. Is that a coincidence? Is it not? So here's what's happening. Okay, let's go back to here. We squared both sides, did we not, over here? So what happens if we want to go back in the other direction? Okay, when you take the square root of an unknown, we have plus or minus, do we not? Usually, for example, we have x squared is equal to 1. Then we know that x is plus or minus 1. This plus or minus is because we're square rooting an unknown. So if we try to go back in the other direction, okay, or even from here to here, okay, so let me write it once more over here. X plus 4 squared is x minus 2 squared, okay? So now what if we square root from here? Okay, the right-hand side will have x minus 2, but here we would have plus or minus square root of x plus 4. this square root and this square root go away, but we still have this square root on the inside. And then we need the plus or minus because we're square rooting an unknown. All right, so if we try to go back, then this is exactly the two curves that I just graphed. This one's the positive, this one's the negative. So this is only giving half the picture of this line right here. Okay, so once again, if we try to go back from here to here, you would have the plus or minus because we're square rooting an unknown. And this is exactly these two graphs right there. Okay, so when we square it, we are technically opening this up to be this parabola. It's a parabola that opens sideways. So before we just had this half of it, because we took the positive only, they only gave us the positive. But when we square it, we're opening it up to have the negative side as well, the other half. So that's why we have these two solutions that we found over here, and then we got to check it. Clearly this one, as you can see graphically, it crosses the one that's the other half that we were not originally given. So that's where the extraneous solutions come from, usually in these square root problems. All right, so that's actually what's happening. Hopefully that's helpful to see what's going on. Actually, why it's called extraneous, it's extra because it's intersecting a different part of the graph that they didn't give us. All right, so again, hopefully this can help you remember why there's extraneous solutions instead of just blindly remembering. Sometimes you check, sometimes you don't. When do you check? When do you don't? I don't like to memorize things like that. I like to understand what's happening. And then it's easier to remember that you should check when we're solving square root equations. It's because of this thing that's happening. Okay, please like this video if you found it helpful. And please subscribe also to show your support, and I'll definitely put more videos out like this as I'm working with my students that I find good ideas to share.